Imagine you're tasked with configuring an EtherCAT node on a V1000 inverter. You've installed the optional EtherCAT card and downloaded the parameters. Now, the challenge is to set the EtherCAT node on the optional card without connecting it to the PLC network or using Sysmac Studio. This isn't just a technical hurdle, it's a critical efficiency issue. Without a direct method, you're forced to use Sysmac Studio, which can be cumbersome, especially during off hours. The question is, can we find an alternative approach to streamline this process? Let's dive into the intricacies of EtherCAT node configuration and explore potential solutions. EtherCAT is a high-speed, real-time Ethernet protocol designed for industrial automation. It stands for Ethernet for Control Automation Technology. Imagine it as a superhighway for data, allowing multiple devices to communicate simultaneously with minimal latency. The protocol uses a master-slave architecture where the master device orchestrates the communication, ensuring that each slave device receives and transmits data in a deterministic manner. This is achieved through a unique feature called the telegram, which is a single Ethernet frame that carries data to and from multiple devices in a daisy-chained network. The telegram mechanism ensures that data is processed in a continuous loop, reducing the cycle time significantly. For instance, in a network with 10 devices, the master sends a single telegram that travels through each device, allowing for efficient data exchange without the need for multiple frames. This design is crucial for applications requiring precise timing and synchronization, such as motion control and robotics. Now, let's delve into the standard procedure for assigning EtherCAT nodes using Sysmac Studio. Begin by launching Sysmac Studio and opening your project. Navigate to the EtherCAT Settings tab. Here, you'll find the Node Assignments section. Select the device you wish to configure. The parameter you need is node ID. Set the value to the desired node number, ensuring it's unique within your network. Confirm the changes and save your project. Remember, the node ID must be between 1 and 127. This is crucial for maintaining network integrity and preventing conflicts. The reason this method is reliable is due to Sysmac Studio's direct communication with the device, ensuring the node assignment is accurate and consistent. Now, let's delve into alternative methods for node assignment. While Sysmac Studio is a powerful tool, it's not the only way to assign nodes. Some devices come equipped with physical switches or rotary dials that allow you to manually set the EtherCAT node number. For instance, the MX2 series from Omron has these switches, enabling you to configure the node without software. However, for other devices like the JC03 or JC06 switches, Sysmac Studio remains the only viable option. It's crucial to understand these alternatives, as they can save time and offer flexibility in different scenarios. Remember, the key is to choose the method that best fits your specific hardware and operational requirements. Navigating the complexities of EtherCAT node assignment can be challenging, especially when dealing with different hardware and software configurations. One common pitfall is assuming that all devices support node assignment through their proprietary software. For instance, while some brushless motors from Minimotor allow node configuration via their software, Omron inverters may still require Sysmac Studio for this task. Another issue arises with devices like the JC03 or JC06 switches, where direct node assignment isn't feasible without connecting to Sysmac. To circumvent these challenges, ensure you have the latest firmware updates for your devices, as manufacturers often release patches that expand functionality. Additionally, consider utilizing offline configuration tools provided by the manufacturer, if available, to pre-configure nodes before deployment. Remember, the key to successful EtherCAT integration lies in understanding the unique requirements and limitations of each device in your network.